So we are continuing, this problem solving in Diophantine equations, focusing on the factoring method. Wait, my video is not getting turned on. Oh, I know why it's not. Okay. Yeah, so now maybe we'll do more harder questions. So you tell me the questions. Okay. So I'll just write the topic. Yeah, your wish. Anything you choose. Okay. Yes. So just a minute. Factoring method. And just for reference, this is T2 and Risco's T2's book. So T2 has this probably only one book on Diophantine equations. So okay. Yeah. Okay. X is a prime. So let me just write it as P. Y is okay. So tell me what you have done. Okay. Mm, no, but there is a conceptual error in that thing. So from here you are saying that A minus B is 2, A plus B is 2 is one possibility, and similarly you will have a few other possibilities. But do you think these are the only possibilities? Are there more possibilities than the obvious ones, than the usual ones? Okay. But see what you have assumed. You have made some assumptions which are pretty different than usual, peculiar in a way in this situation. Do you notice? This assumption means that A is no longer an integer. A minus B is no longer an integer, right? So is it fine that there should be more possibilities? In fact, these possibilities will never lead to legal solutions. On the surface, they look like, right? But they will not lead to legal solutions. Like P will not even be prime. You will get a P to be some perfect square when you. So yeah, you are bound to. Yeah, because you are forcing root P to be an integer. So, so there goes the conceptual error. Now think. So still, the large thing that is given away is that it's factoring method. So you have to factor, right? It's already being told to us. Think, take some time and try it, because yeah, I mean I know the trick of this question, so try. Yes, as you know, that is correct. Hmm. Okay. So that's there. That's the thing, right? But still, let's try to complete the problem. Yeah. Try to take it completed from here now. Right. So then what will be the possibilities? In fact, there will only be one possibility, but maybe uh, no, I think you are right. So, yes, right. Y can be negative also. So you are saying that this is, yeah, but the point is that what I am telling is this that this you can consider. Okay, tell me one thing. Are you going to consider? See, these are the small. So in the beginning, they are just small simplifications, but later on, you will see that we are exploiting certain symmetries. Like -1 is a symmetry of the integers, right? Because it's like when you multiply the integers, every integer by -1, you again get back the integers. So you are using some symmetries, and you'll see that point maybe over time. But tell me that will you be considering this thing? No, right? It's not possible for this thing to be negative. So you won't be. So already you have cut out the using. Now I'm saying that you don't even need to consider this situation, because if y is negative, then -y is also a solution, right? Means I'm saying that if y is a solution, then -y is also a solution, right? So any solution where y is negative can be gotten from some solution where y is positive. So that's the symmetry, right? And so you don't need to consider that. These are just small simplifications, but they will be useful. Okay? Now you just finish this. Right? P equal to 5, and then -1 comma 5 is also a solution. Yeah. So it is pretty easy. There is this very standard factorization which you have done. This is a trick. It's this is it has a name. You can see it's not needed, but it has a name. It's called Sophie German identity. So it's whether it's German or something. I don't not very sure, because I don't know what that is supposed to. What's the sense of that word? Yeah, identity. It has some deeper meaning. It has some slightly more interesting meaning, but for us it is this much is fine. Because usually sum of squares, they don't factorize in the usual sense. But this particular sum of squares factorizes, right? And that's why it's a nice one. So just to tell you a little bit things, that usually sum of squares don't factorize, but this particular sum of squares is a sum of squares, right? Special kind of sum of squares, very, very special kind of sum of square, but it is a sum of squares, factorizes. Okay, and that is the thing. Okay. You will, so you see, basically factorizing is very, very nice, right? Because when you can factorize something, then you can compare it with the factorization of the number and get your possibility. So we always are looking to um, factorize things. Okay. So far, we know that we don't want to we don't factorize these things, but soon you will start factorizing them. And that's when you will go beyond integers to understand integers. You will soon start factorizing them like this, okay, and using it. So let me ask you this question maybe. This is, hmm, let's see. Okay. So let's say that this is equal to 14. Okay. So like, okay, let's say somebody gives you, obviously maybe you can do it in many ways. That's not the point. But if you want to do this by factorization, and if I write like this, I mean, so far there is nothing wrong that I have written, right? Given what I is, given the definition of I, it is fine, right? We have gone to a bigger class of numbers, but the rules there don't violate the earlier rules that you had in integers, so it's not a problem, right? Because whatever you learn there, you can apply it to integers because the rules don't get violated. But then, can I say that this is a possibility? Obviously, I can. Nobody stops me, right? It's okay. But what are all the possibilities? Right? That is the problem, right? In this case, what are all the possibilities? So here you will learn very soon, maybe, that, I mean, obviously you can factorize this also in the similar way. And then you will know that 7 cannot be factorized in this way. Okay, you can try doing that, even see it will not work. But then you will prove later on that certain primes cannot be factorized even if you allow I. Okay, so this. Now you see, now you can say that, okay, I can take a plus ib as 7 and a minus ib as this, right? Things like that, although you see that that doesn't work, right? Now, obviously you can say that this has no solutions in fact, but that's a different point. Maybe we can make it 16, right? So 16, and again you can compare things, but why can you compare? Like, why can you get all the possibilities in the same way as you got for integers, right? So why can you still say that, for example, this should be this and this should be this? And similarly, you can write the possibilities. That is fine, you can write those possibilities, but if you think carefully, the real question comes, why are there no more possibilities? Do you see that point, right? At the end, the question that the mathematician asks is, why are there no more possibilities? That comes down to the fact that, again, unique factorization, right? The number 14 can be uniquely factorized. If you factorize it into primes in this world, then there is a unique factorization. So if there are two factorization, then, yeah. So if this is, if you have to break this into two factors, then you have to take primes and their multiplicities from these factors only. That comes down to the unique factors, and that one has to prove that in that world where you have integers and I, and this is all that is allowed, no fractions and I, no omega, no cube root of unity, only these. In this world also, factorization happens in the same way. There is a uniqueness in the factorization, and then you can do. And you see, this is actually helping you to understand integers. In the end, you are able to answer questions about integers by going beyond integers. You see, and it becomes necessary to go beyond integers for certain questions. Okay, all those things you will learn, that somehow it becomes necessary. In fact, why is it necessary? That's a philosophical question, but okay. But you see how it can, if you go beyond the rules, you can fact. I mean, we are always going beyond the rules if you think about it, right? Just that we're going one step more in this. So these are the small things that you have to just, watch out for. And it's there in that book, which is your, this is book, but it takes time to read that if you can. Okay, let's move on. Let's, hmm, okay. So what have you done for this? uh Okay. Yeah, so this factorization, is it a good, I mean, it's correct. Logically, it is correct. But does it take us in the direction we want to go? Yeah, it's from here it's difficult to reason, right? It's so this is not a good, and you know that this is not a good factorization, right? You know that from earlier examples. So again, you are doing the wrong kind of factorization, like you were doing in the first problem, but now you try again. I hope you will be able to do the correct factorization. I don't know. Let us try. Don't know what's the correct or hmm. No, it is x square plus 1. No, no. x cube whole square. This one is correct. Yeah, but then this was not good. Something. I'm trying to get that a cube plus b cube plus c cube minus 3abc. Okay, um, but I'm not successful. No problem. If we just factorize it more, hmm. um, x square, if I just do x square plus 1 whole cube, yeah, this is a nice problem. We have to, no, it is not this. I mean, it cannot be this. Yeah, because I don't know how to mix the y on this side. There is only one y. So this is just a, so this problem is just saying that this cannot be a fourth power for too many, you know, for too many things, right? Or, yeah. Hmm. X cube plus 1 whole square plus x cube. Yeah, this is what it is. We can try something like this. So, but I've not written it as a fourth power, but x cube plus 2 whole square. Can we check how much that is? You know, this is the one of the tricks that I know. 6x cube, right? And this thing is, no, yeah, hmm, okay. So, yeah, so this one is, yeah, so this one is bigger than x cube plus 1. No, and yeah, so we will come to that. So this is bigger than this, strictly bigger than this, if x is positive, right? So yeah, so all I am saying is that uh, this y to the power 4 is bigger than x cube plus 1 whole square, because it is this if x is positive, and it is less than x cube plus 2 whole square. So it's not, this is not possible. Then y cannot be a square. So so x cannot be positive. Again, we are changing the technique, but then what, right? So the other case maybe will be, so now we take x to be negative, and then I don't know, suggest some factorization, though ideally it should not suggest anything new. But you know, because there is a certain thing in the equation, you can see that there is a certain power game, right? Then we want to solve for this, where now again we can assume that x is positive, right? So, so that there is no confusion, we are saying that let x equal to minus, maybe we can use some other symbol, right? Minus n, where n is positive, right? Then what does the equation become? Okay, yeah, yeah. Now I don't know, does it suggest anything? So it is bigger than, I don't know if, but let's just try to see if we can factorize this. I don't see how this will suddenly lead to a factorization, because earlier also I was considering negative cases. But again, you see, so this means that what we have is this is bigger than uh, y cube, this is bigger than n cube minus 1 whole square, right? Same thing. And it is less than, and is it, so you try to see. So first you see that obviously n is equal to 0 is there. That solution is there, right? That you can work out, that is there. So n is not 0. Okay, so n is the natural number. Okay. Now tell me, what do you agree with? Is this okay? Yeah, it is bigger than the strictly bigger, like there is no question being equal. Is this correct? So this one may not be correct, right? So this one may not be correct. Yeah. So what I'm saying is this is this. Yeah, I think it is strictly less than, right? Yeah. Even is, yeah, it is correct. Hmm. So it's again not possible. So yes, I don't know. Then n equal to 0 is the only solution. With that you get values of y. But I'm not very happy with this one. So let's look at the book and see the solution in the book. Yeah, we should just see what should learn what they're doing. We have missed something. We should have a look. So let me show you. You can see this together. Just a minute. I have to eat this thing. It's lying there since a long time. I'm not able to think of any factorization method. There should be, so there is something to learn. What is the problem number? Ah, sorry, I was muted. Okay. I'm on you can hear me now? Yeah, but you can see the screen. And wait. Oh yes, yes, because I did not. Yeah, sorry. Oh, it's stuck there. Yeah, because I had chosen and I changed the window. Hmm. I mean, I can share the screen directly. That's better, but yeah, I should just do that. So maybe the next one. So yeah, we missed it basically. You can see. Yeah, means I don't know. We were not simply not doing it. I mean, this was we were getting here, but then we didn't write. Yeah, kind of. Hmm? Once you do this, then you have this. Now you can see, right? You can go on. Now let us see if our conclusion is correct. Yeah, at least our conclusion was correct, at least, right? So just have a look at this once again and see, if you have anything to say here. Oh, you mean this one? Coming from there, how is it coming? Yeah, that's a trick. That's a trick, right? They multiplied it by 4. So I don't know if you can see if when I write. No, you cannot see. Yeah, just take this equation, yeah, this first equation, and multiply by 4 everywhere. You understand, right? Then it becomes factorizable, right? So that is a trick. I'll just write it on the board. And that's the only thing. Other than that, there is nothing. Wait, then where is my screen? Wait, can we just, yeah, okay. You can see my screen, right? Whiteboard? So this one is just, yeah, but this is, right. And then you multiply by 4, right? And now you see what is going on. Oh, yeah, because I don't know, this is some other gadget which has got shared. All kinds of things are there, you know. Why cannot I just share my screen once? Oh, yeah, I can. Hmm. Now you can see, right? Yes, so then that's it. Yeah, 2x cube plus 1, this thing, and no, this is 4, so 2 into 2. So there is another 2, but how do you then take care of, how do you take care of that? Um, yeah, this looks very strange. Oh, I'm just forgetting everything, right? That's the thing. Yeah, okay, no problem. So we just do the natural things, right? So if you have this kind of quantity, then you need this kind of quantity, right? So that is fine. Now you want to complete the square, so you add a 1, right? Okay. And then you complete the writing it here. You complete the square. So 2x cubed plus 2 plus 1 whole square. So this is a square. But then again, and then again, can move forward. Right. Yeah. This one is probably the hardest one so far. But this is just the beginning, I think, right? But you see, it's like that, right? We did it in some other way as well. Okay. And in fact, we showed that even if you take y square here, there are not any interesting solutions, right? So we showed something more. Okay, even if it's y square, there are no solutions. So, if it's y to the power 4, that's also y square. That's also square of y square. So this is, and then there is the other method. This method was there, but I don't know. I somehow, yeah, I got afraid of that y maybe. Yes, it's true. In a way, that's how I feel now. I got afraid of that y. Okay, so yeah, maybe then let's stop here today. Okay, let's meet on Friday. Okay, we learned a few techniques. I want you to understand that principles. So you see, the more problems you solve, we have to start zooming out and understand things on the level of principles. Okay, more, like with lesser principles, with how you can generate more things on your own. See, that's what you have to gradually do. That's the thing. Like if you go look at the school level, like they're like just we continue to do the same thing 100 times. J is also similarly, but little bit similar. But you have to learn to, yeah. Yeah, so let us stop here and then, um, yes, let's meet on Friday. But Friday we will not discuss this one. Um, yeah, what should we do on Friday?